Hi guys, and welcome back. In this video, we will be looking at the causes of climate change in the past. This is an essential part of the climate change debate for the specification, and I have included an 8-mark exam style question to give you an idea of what you could be asked in the exam. I will also do a video on the human causes of climate change to help with the other side of the debate. I will link it in the description, and it will also be available in the Hazardous Earth playlist. Okay, let's get started. Okay, we'll begin with a bit of a background before we move on to the causes of climate change in the past. Now, this particular graph that you can see here shows how the concentrations of carbon dioxide in the atmosphere and Antarctic temperatures have changed in the last 800,000 years. Now, the main things that I'd like us to note is that one, both have fluctuated over time with peaks and lows. Now, if you look at both graphs, this one here shows the atmospheric carbon dioxide concentration, and that is shown in parts per million here. And then you also have the Antarctic temperatures, and that obviously is shown here in degrees Celsius. So they have both fluctuated, so up and down, up and down, up and down. And then secondly, they also appear to be correlated. So it looks as though when as the carbon dioxide levels go up, the Antarctic temperatures also rise. So that is true for most of the time, apart from just a couple of anomalies here and there. But overall, the pattern is very similar. And then the last thing I'd like us to note here is the recent spike. So that spike here that has taken place more recently. Now, if we look at the fluctuations that have taken place here, the highest that the carbon dioxide concentrations in the atmosphere have really gone up to before that is just below 300 parts per million, or we could just say 300 parts per million. So they have not necessarily gone beyond that in the past. However, more recently, there has been a massive spike, and the concentrations have gone up to almost 400, actually just slightly beyond 400 parts per million. Now, we know that that spike in concentrations of carbon dioxide in the atmosphere have occurred since the Industrial Revolution. So since that time, there has been an increase in in industry, or the number of factories. As a result of those factories, there has been urbanization, because with factories means jobs, and with those jobs, and most of those jobs are likely to be in urban areas, people are likely to move from rural areas to go and work in those factories in urban areas. Then there's a need for energy. Now, that need for energy is for the industry, as well as the people who are urbanizing this area. So as more and more houses are built, and as the population continues to increase, then there is a need for energy. So that when you're producing electricity, for example, or energy for that matter, you're likely to burn fossil fuels. So for example, gas central heating is used here in the UK quite a lot. So that is the use of gas for central heating. Okay, so energy is needed in urban areas, and that is likely also to cause the carbon dioxide concentrations in the atmosphere to go up. Then we have food as well. As the population increases, we need a lot more food, and when we are producing food, the farm machinery is likely to produce carbon dioxide, and then also if we are talking about rice paddy fields or ranching, where you're keeping cows for beef, then or cattle for beef, then that produces methane as well. So increases the greenhouse gases in the atmosphere. Then we have transport. Obviously, as people become, as places urbanize and people make more money, then they are likely to have cars as a means of transport, and that again increases pollution levels. And also there's the issue of people getting more affluent by the day. and because of that, then they demand more of manufactured goods and products. Like the white goods that are used, white goods that are used in the house. So if we are talking about fridges, we are talking about dishwashers, washing machines, microwaves, tumble dryers, and so on. All that is produced obviously in the factories, and that requires energy as well, leading to more carbon dioxide being released into the atmosphere. So the conclusion then is that this recent spike is as a result of those all that activity or human activity that has then precipitated the burning of fossil fuels. So then that then implies that the highs and lows in the past were down more to natural causes other than human causes. So these spikes here were more natural than human. And that's where now the causes of climate change in the past come in terms of there being another factor that was influencing climate. So those are likely to be natural causes other than human causes over here, which are the main factor here. Okay. So the question is then, because we'll talk about the causes of climate change in the past, so the question then becomes, what caused the lows in the past? So the highs and the lows in the past, because you can see that sometimes there are some significant lows, and then you have those highs that go up to around 300 parts per million of carbon dioxide concentration in the atmosphere. And then in terms of the temperatures, you have very low temperatures and you have higher temperatures. And these low temperatures here are what could be referred to as glacial periods, when it was really, really cold. And when it's really cold, then it means you may even have an ice age. Okay. Then the ones where the temperatures increase a little more, those are interglacials. So there are periods when it's warmer and there's not as much ice around. Okay. So the question then becomes, yes, like we've just discussed, what has caused the highs and lows in the past? And this can be explained by the concentrations of sulfur dioxide, which is another gas. Okay, so it's not just carbon dioxide, but sulfur dioxide. Sulfur dioxide reacts with water vapor to form tiny sulfuric acid droplets, which are referred to as aerosols. Okay, so SO2 obviously plus H2O, which is water, normally produces H2SO4, which is a dilute concentration of sulfuric acid. And that's what we are talking about here as acid droplets, which are referred to as aerosols. And these ones are normally present in the stratosphere. Now, the stratosphere is the second layer of the Earth's atmosphere. These aerosols reflect incoming solar radiation back into space. Okay, so as the solar radiation comes in, so we have shortwave radiation trying to come in. As it tries to come in, it's then reflected back into space by these aerosols that are now in the stratosphere. Okay, now that causes temporary global cooling. So the temperatures are likely to drop as a result of that. And that is known as the haze effect or volcanic winter. So we are going to go into that in the next slides. Let's carry on. The first cause of climate change in the past is volcanic eruptions. Now, large volcanic eruptions can alter the Earth's climate. When they erupt, they release huge clouds of ash and sulfur dioxide into the atmosphere. So we have just talked about sulfur dioxide. We have talked about the reaction of that sulfur dioxide with water in the atmosphere to form aerosols, which then are present in the stratosphere. Okay, so we've established that. Now, if the eruption is big enough, the ash cloud and sulfur dioxide rise high enough to reach the stratosphere. Here, they will be transported around the Earth by high-level winds. So, the The ash cloud, like you can see in this picture here, this is a massive ash cloud that is going into the atmosphere, and sometimes they are spewed for a significant length of time. So it's a lot of ash. So when it gets into the stratosphere, it's transported across the world by high level winds. Now the aerosols created by the sulfur dioxide, like we had discussed before, and the ash will then, because now it's more in the stratosphere, it will reflect a lot more rays back into the atmosphere. And as a result of that, it leads to what is referred to as volcanic winter, which we had mentioned in the previous slide. And this is the global cooling effect, where the ash and sulfur dioxide, the aerosols rather, reflect the rays of the sun back into space. Now, the other way you can actually simply describe that process, if you were in an exam situation and you did not remember the scientific part of it about aerosols and about the sulfur dioxide mixing with the water, you can simply say that the ash clouds that goes into the stratosphere will block the rays of the sun, or some of the rays of the sun, from reaching the earth, and therefore the temperatures on earth are going to drop, or they are going to become lower. Okay, that's a nice and simple way of describing this process. Now, an example of an eruption. So actually the most powerful eruption in recorded history was Mount Tambora in Indonesia in 1815. So that particular eruption led to a global temperature decrease of around 0.8 degrees Celsius. Now that caused crop failure and famine across continents, leading to what is referred to as the year without a summer. Okay, so the temperatures dropped so significantly that year was described as a year without a summer. Okay. Then the most recent one is Mount Pinatubo, and Mount Pinatubo erupted in 1991 in the Philippines, and that also caused a drop in temperature of 0.5 degrees Celsius for several years. Some reports say several years, some reports say for 1 year. Okay, but that's significant, because if one eruption then can interrupt the global, the temperatures by 0.5 degrees Celsius, therefore, impacting on global climate, then that is quite significant. Okay, so let's go on to the second reason, why the second cause of climate change in the past. The third cause of climate change in the past is asteroid collisions. Now, asteroids are rock-like remnants left over from the formation of the solar system. They are composed of rock or metal, or sometimes a combination of both. So again, very large asteroid collisions can alter the Earth's climate in a similar way to volcanic eruptions. When they collide with the Earth, as in the asteroids, they also release huge clouds of ash and sulfur dioxide into the atmosphere, blocking the rays of the sun from reaching the Earth, and therefore causing a drop in global temperatures. So again, asteroid collisions, they are similar, their effect is similar to that of volcanic eruptions when they collide with the Earth. Then moving on to the third cause of climate change in the past, we are talking about sunspots. And sunspots are black areas on the Earth's surface. Now they increase or decrease through the solar cycle, and that solar cycle lasts 11 years ordinarily. So within that 11-year cycle, you may get an increase or a decrease in the number of sunspots that the sun has. And when the sunspots increase, the sun becomes a lot more active, and it leads to higher temperatures and vice versa. So when you don't have as many sunspots, then the sun is less active, and therefore the temperatures are not as high. And again, this can alter global climate. Okay, so next cause. The fourth cause of climate change in the past is the orbital theory, or what is also commonly referred to as the Milankovitch cycles. So scientists have claimed that the orbital theory is responsible for the glacial periods and ice ages of the past. Okay, so these here are what have been said to be the cause of the glacials and interglacials. These periods were 6 degrees colder than the current average global temperature, and some of the interglacials were 3 degrees warmer than it is today, or than today, as in than today's average global temperatures. This was caused by changes in the sun's orbit. Okay, so these changes in temperature as a result of the Earth's orbit. Okay, it should say this the Earth's orbit, not the sun's orbit, because it's the Earth that orbits the sun. Okay, so apologies there. That's my mistake there. So there are 3 main changes that can take place in the way the Earth orbits the sun. Okay, now and the first one has to do with the shape of that orbit. Now you can see here that the first one, the dashed line here, is more of a circular orbit. Okay, and then in sorry, the cursor was not there, so you couldn't see that. So that dashed one there is a lot more circular than this one here, which is a lot more oval or elliptical. So every 100,000 years, the shape of the Earth's orbit around the sun will change from circular to elliptical and back again. Now this means that the amount of sunlight that the Earth receives will change, leading to changes in global temperatures. So if you have a circular orbit, it means that the sun's rays are going to be, fairly constant because it's more of a circular orbit, so the radius almost mostly remains the same. Okay, but if it's more elliptical, then in some cases the Earth will be a lot farther away from the sun. Okay, like when it's going to orbit, when the Earth is orbiting it's in that position, then it's a lot farther away. But if it orbits to this position here, it will be a lot closer. So that kind of situation there, or those differences there in the shape of the orbit that occur every 100,000 years will have an impact on global temperatures, will either cause them to reduce or to increase, therefore meaning that they determined the glacials and interglacials of the past. Okay, and then the second change that can take place in the orbit of the Earth around the sun is the tilt of the Earth. Now the tilt, every 41,000 years, the tilt of the Earth can go from being upright or more upright to more elliptical. Okay, so if it's upright, obviously it's not tilted a lot more to its side, it's a little more upright. But then when the tilt is a lot more, then the angle of that tilt will change, and as a result, again, as the sun orbits as the Earth orbits the sun, there are going to be differences in insolation, so the amount of solar intensity that we are getting here on Earth, and that obviously is going to alter the Earth's temperature it's going to alter the Earth's temperature. Okay, so that's the second change that can take place in the Earth's orbit. The last one that can take place is the Earth's wobble, and this happens every 26,000 years or so. So as the Earth orbits the sun, it's rotating on its axis at the same time. So this Earth, well, it's rotating, it's spinning, okay, but also revolving around the sun, okay. But every 26,000 years, the Earth's axis will wobble like a spinning top, okay. So this again will lead to a change in insolation and therefore alter global temperature. So these 3 changes here in the Earth's orbit are what are referred to as the Milankovitch cycles, and they are also what has been used by scientists to explain the glacial periods and interglacial periods of the past. Okay, so those are four causes of climate change in the past. And there's an exam style question here, and this one says to assess the view that human activities causing climate change have become more important than natural causes. So in this question here, you'd be arguing, you would be debating whether human causes of climate change are more significant nowadays than the natural causes that took place previously. So the natural causes being volcanic activity, over volcanic eruptions, asteroid collisions, sunspot activity, or the Milankovitch cycle. So that is what you'd be discussing there. And the information we've covered it would be quite useful in doing that. And that's an 8-mark question. That brings us to the end of this video on the causes of climate change in the past. The video on human causes of climate change will be linked in the description and will also be available in the Hazardous Earth playlist. It will provide information on the other side of the debate, as there are both natural and human causes of climate change. Thanks for joining this journey to good exam results. All the best and see you again soon.